Assalamu alaikum. Welcome again, students. So, this is the second video of your Unit 2, isn't it? So, we were talking about fractions. What is fraction? A fraction is a part of a whole. Okay, a part of in a whole. Uh, Anything which is complete, a part of that will be your fraction. Okay, so we had seen many examples. Okay, so we were at this particular scenario in which you can see this there is this is a container, right? So in which you have any stuff you can put in this. Here we are using rocks, so two rocks are placed in this first figure. So the capacity of this container is how many? 3 rocks. It can have accommodate 3 rocks in this particular container, right, of this size. So in this so your total this thing is fraction, you can write it as 2 upon 3 because it can accommodate 3 rocks, okay, total, but we have only 2 rocks placed in this container, so this will be 2 by 3. So similarly, when you come at in this figure, so we are trying to accommodate, okay, 4 rocks, 1 2 3, and this is 4, which is not possible. Okay, so this is getting overloaded, this container is getting overloaded or heavy. So that is why that your actual this thing is capacity of this container is 3. So you are taking this in the fraction down part denominator, but you are trying to accommodate how much? 4. So 4 by 3 will be your fraction, which is nothing but this is your example of improper fraction, right? Because improper fraction you have it becomes anything which becomes improper whenever you load heavy things. Okay, so numerator is becoming heavy, that is in your improper fraction numerator is always greater than denominator. Okay, so that is why this becomes improper fraction. So I told in the last class all the improper fractions are always greater than or equal to 1, and all your proper fractions, they are always less than 1, isn't it? We are just accommodating below the capacity, okay, to make sure that it doesn't get overloaded. Okay, so this becomes your proper fraction, and always here numerator is less than denominator. So obviously your the resulting number of your proper result of the proper fraction will always be less than 1. Okay, all right, so let's move on. So we've seen what are mixed fractions. Also, what is mixed fraction? It is the combination of the whole number and a fraction. Okay, you'll have a whole number and a fraction in mixed fraction. Alright, so that's why we call it as a mixed fraction. See, if I take this as 4 2 by 3, okay, I'll represent this in pictures. Okay, so what is the if I take suppose a circle, okay, I'll represent it with a circle. So I have full 4 whole circles, okay, and one circle, it is in fraction. So one circle which is in fraction, it is divided into 3 parts. All right, so something like this. Okay, So if I take this is divided into, one second. So in this if I take the last one as it is divided into three parts, isn't it? But the shaded region will be only 2. Okay, this is 2 by 3, and the rest 4 are, they are whole 4. Okay, so we have 1 2 3 4, they are whole 4. Okay, completely 4 circles. And the fifth one, it is a fraction. Okay, the part of the whole, that is 2 by 3. So we have 3 parts in this. So out of these 3 parts, it is, we used one is only 2. Okay, so it is 4 2 by 4 2 by 3. So in this way you represent your mixed fraction in your pictorial form. Okay, I hope this is clear. I'll take one more example how to draw. Okay, so now what you will do, you will have some problems on your conversions, that is mixed to improper. All the improper fractions can be represented in your mixed fractions. Okay, and so this will be equal to, in the last class I think we have discussed, this is nothing but 4 3 is 12. Okay, plus 2, that is 14 by 3. This is equal to 14 by 3. Let's take few more examples for the conversion. So this is 3 1 by 2. Okay, so if I convert this into improper fraction, what you'll get, it is 3 into 2. Okay, plus 1. So 6 plus 1 is 1 by 2, it is 7 by 2. So convert this, 7 3 is 21, 7 4 is 28. Okay, you need to multiply here and then add here. So 7 4 is 28, 29, 30. This is 30 by 7. Okay, okay, so and then this one you have this is what, improper fraction, isn't it? So because numerator is greater than denominator, so this is improper fraction. So I can convert this improper fraction into mixed. How? Just go for division. Okay, like this. So you take 9 and 5. So 5 ones 5. You have a remainder of 4, isn't it? So you write this is your whole. Okay, this will be 1. Okay, how? 1 4 by 5. Okay, so let's do one more problem. So this is your 7 by 2, which is improper fraction. Okay, I will divide this 7, okay, by 2. Alright, so how much you'll get this, 2 3s are 6, 1 will be remainder. Okay, so how you'll write now, mixed fraction. So you need to take the whole. Okay, this is quotient, you'll take this as an answer. Okay, quotient, remainder by your this dividend. So this, see, by 2 will get from your question itself. Okay, so the answer is with your quotient, which is a whole number, so that will come here. Oh, and it will be 1 by 2. So if you just convert this, see, try to convert this, 3 to 6, 3 into 2 plus 1 is 7 by 2, the same we got, isn't it? So this is how you convert mixed fractions to improper and improper fractions to mixed fractions. Alright, so I will show how to draw this diagram. Let me draw the diagram or the pictorial representation of this mixed fraction. Let me draw for this first. Okay, this is improper fraction. So anything, let me take, you have a container. Okay, so in this container what it can accommodate only 2. Okay, same as that. So it can accommodate 1 2, but you're trying to accommodate how many? 3 4 5 6 7. Okay, so it is overloaded. So what we will do, what is the solution? You need to take 3 holes and the other one as this. Okay, let me show you this. So we are taking, so this is for your improper fraction. Okay, so this is all overloaded. So if you go for this mixed fraction representation, equivalent, this is the equivalent diagram of this can be the whole. Take 3 containers, okay, which are whole with the proper fraction, and in the second container it has 2 this division, it can accommodate 2. Okay, but the used part is only 1. So this is the 3 representation of 3 whole number. Okay, and the fraction part will be represented like this. Okay, so this is how you are, what you are doing, you are accommodating 2 in each whole container. Okay, which is a sufficient one. Okay, 3 containers you took whole, and in the third container what you are doing, you are accommodating the one part. This one is left out, isn't it? So one part you are accommodating in this, or the other one is left empty. So the fraction you are representing for this container as 1/2. Okay, so I hope how the pictorial representation it's clear. You need to understand the concept over here, so that's why I'm taking more and more examples. So let me draw the pictorial representation of this. Okay, so again, and it can be anything. Okay, it can be a circle, it can be a container, or anything. So when I'm taking container, it's becoming easy for me to divide. Okay, so let me take again, if you want me to take a circle or a container, so this one is, I'll take circle. One is the whole circle. Okay, and in the second circle, this is represented in fraction. Okay, that is 4/5. So this circle, it should be divided into 5 parts. So if I divide it into 5 parts, 1 2 1 2 3, yeah, 5, isn't it? 1 2 3 4 5. So out of 5 parts of this circle, how much is used? Only 4. So I will shade the 4 regions of this circle. So this is how you represent pictorially. Okay, so each circle, it is divided into 5 parts. Okay, so this 1 2 3 4 5, yeah, equally it is divided. So one whole represents, this whole circle is shaded, all the parts are shaded, and the second circle, which is in fraction, that is 4 parts are shaded. Okay, only one part is left. So this circle is accommodating 5 regions. Okay, out of 5 regions we are just using 4. So 5 is the this part, how many you can accommodate in the circle, but the used one is only 4. Okay, so this is how you represent your mixed fraction in pictorial form. Okay, in your previous year you have already learned about how to add your fraction, subtract, multiply and divide. Let us quickly revise those things today. So for addition and subtraction of fractions, if see this is what 6/4 plus 3/4. It is easy when your denominators are equal. What you will do, you will just add the numerators. Okay, because denominator you have 4 4, they are equal. So such kind of fractions you call them as like fractions, isn't it? So if denominators are same, it's very easy for you to add, like 1/2 and 5/2. So you can easily add this as 5, take denominator as 2, and 5 plus 1 is 6. So it's easy when your denominator, that is fractions, if they are like fractions. Like fractions, what? Denominators are same. Now when the problem comes, it's in addition. If you have unlike fractions, okay, 2 by 3 plus 1 by 5, in denominator you have 3 and 5 different numbers, isn't it? So you can't add like this, just take 2 plus 1 by 3 plus 5. Normally student does mistake here. You can't go for this kind of addition. Every time when you add or subtract, you need to have like fractions, that is denominators should be equal. Okay, so this kind of fractions we call them as unlike fractions. Okay, so you need to first make these unlike fractions into like, okay, like fractions, and then you can go for addition or subtraction. Okay, so to make this unlike fractions into like fraction, you have two methods. Already you have done this, so we are going it a bit faster. Okay, so what I'll stop here after showing these methods. So you have example, we took it as 2 by 3 and 1 by 5, isn't it? So we are converting 2 by 3 and 1 by 5 into like fractions and then add them. So how to convert this? First, what you will do is you need to find a multiple to make these two fractions denominators same. So if I multiply this denominator with 5 and here with 3, what will happen? You will get 15, 15, isn't it, in your denominators, right? So that is what we are doing here. So 2 by 3, we are multiplying. So if you want to multiply it in denominator, obviously you need to multiply it in your numerator, isn't it? Or so that when it gets cancelled, it will remain only 2 by 3. So your this will be 2 by 3 into 5 by 5, so you'll get 10 by 15, right? 5 2 is 10 and 5 3 is 15. Okay, so in this we had seen, to make it 15, what you'll do, you need to multiply it with 3. So we are multiplying it with 3 here, both numerator and denominator. So you'll get 3 by 3 into 1 by 5 3 is 15, isn't it? So you look at this, so both the denominators are equal. Okay, now you can easily add these two. So 10 plus 10 by 15 plus 3 by 15. Okay, so it will be 10 plus 3 by 15, that is nothing but 13 by 15. Okay, let's stop here, students. We will continue this in the next video, inshallah. Until we meet, I would like to take off from you all. Assalamu alaikum wa rahmatullahi wa barakatuh.